Okay, so we've got a point, -2 comma 3, and we've got it set up so that it makes an angle with the x-axis, so it looks like one of those reference triangles we've been working with, where you draw that line down to the x-axis or up to the x-axis. Anyway, we know the side lengths because we know that we go over -2, we go up 3. It's that rise over run, the thing we've known. So we do know the lengths of the sides. We just need to figure out what that hypotenuse is before we can do anything. So let's use the Pythagorean theorem here. So here we have the Pythagorean theorem. We've got a squared plus b squared equals c squared. We're basically going to plug in these points for a and b, and then we're going to use that to solve for c. The hypotenuse is always c, the longest point. So in this case, I've labeled our hypotenuse r, so let's rewrite this so it applies to our situation. So we've got 3 squared plus -2 squared equals r squared. And so we want to solve for r. So we can first evaluate these, or we can just take the square root of both sides. Let's take the square root of both sides, just so we have an equation to work with every time. So we have this. So taking the square root of r squared is just going to give us r. So then we get r equals the square root of 3 squared plus -2 squared, which is 9 plus 4. And then so 9 plus 4 is 13, so r equals the square root of 13. And like I said in class, we are going to leave it in the square root form. It is the most accurate answer. It's more accurate than rounding it. All right, so now we want to find the sine, the cosine, and the tangent here. So we know all three sides, right? So now it's just going to be a matter of using SOHCAHTOA. So the first thing we're looking for is sine theta, which SOHCAHTOA tells me is opposite over hypotenuse. And in our case, that is 3 over the square root of 13. So let's plug that into Desmos. Sine is 3 divided by square root 13. And again, we're going to leave it in this form. We're not going to turn it into 0.8321. So we're going to leave it in that fraction form. So we still want to find cosine theta and tangent theta. So let's set those up. Cosine is adjacent over hypotenuse. And then adjacent is -2. Hypotenuse is square root of 13. So it's -2 over square root of 13. And then tangent is opposite over adjacent. So opposite is 3, adjacent is -2. So it's going to be -3/2, or -1.5 is fine because it's still exact. So let's go plug those in. Here we go. All right, in the graph, draw the reference triangle for this point. So we're just going to drop a perpendicular line down to the x-axis. You're always going to either go down, or if your point's below the x-axis, you're going up. But you're never going left or right. So it's always going to be, because we're always looking at this angle. So you're either going to be drawing that line up, or you're going to be drawing it down. Anyway, so r is what we're going to call the hypotenuse in this situation. We got to figure out r first. That's the first thing we want. And then we're going to figure out sine, cosine, theta. So basically the same thing we did in the warm-up. So our side lengths are -3 and 7. So we're going to use the Pythagorean theorem to figure out what our hypotenuse is. So we have r equals the square root of 3 squared, -3 squared plus 7 squared. We're going to simplify that down. 3 squared is 9, 7 squared is 49, 9 plus 49 is 58. So then r is going to be equal to the square root of 58. So that's this length right here. And then now let's just fill in our SOHCAHTOA, right? So sine is opposite over hypotenuse, 7 over the root 58. Cosine is adjacent over hypotenuse, so -3 over square root of 58. And then tangent is opposite over adjacent, so 7 over -3, or -7/3. So now we can just go fill this into Desmos. And it looks like they all check out. So we're going to do the same thing again. This time we're down in the fourth quadrant, so it's going to change the line we draw a little bit, but otherwise it's going to be the same process. So with this one, we're going to be dropping a line down. Remember, we're always making the angle with the x-axis, so that means we're going to draw the line up from that point to the x-axis again. We're never going side to side. We're not doing any of this. So it's always going to be this, and then this is going to be our angle right here. Angle's always going to be at the origin. Okay, so let's get this into a notepad. So we've got our two side lengths. Now we need to find the hypotenuse first. So let's just plug those into our equation for the hypotenuse with the mean we made up with the Pythagorean theorem. We're going to have the square root of 6 squared plus negative 10 squared. Then we're going to simplify that. 6 squared is 36. Negative 10 squared is 100. So we're looking at the square root of 136. Square root of 136 can be simplified. Don't think I'm going to require this year, but you could also write this as, let's see, it would be the square root of 4 times 34, which equals 2 root 34. That would require you to simplify your sines and cosines a little further, but I think for now we're probably just going to stick with this because I don't want to spend a day learning how to do that. This would be, if you're going into calculus, keep that in mind though. Anyway, we've got 136 as our hypotenuse, so we can even just go in and write that in any of the ones we have a hypotenuse in. And also let's just add in the things we know, right? So the adjacents are 6, and then opposite is negative 10. And there we go. Let's go put that in Desmos. So it looks like everything is here. This was negative 10 sixths, but look what it says. It says simplify, right? We can divide both these numbers by 2, so that would be 5 thirds. And there we go. All right, slide 6. We're going to do this with 1/2 and root 3 over 2 now. So first thing we want to do is snap a line from there to the x-axis. So we've got our triangle now. And then this is going to be our angle, the one that's sitting at the origin. And then let's go label our triangle. So this was root 3 over 2. And this one was 1/2. So opposite is going to be, oh, actually we need to find r first, right? So let's plug in 1/2 and root 3 over 2 down here. And we'll show a little more work on this one because it's got the fractions and everything. So we're going to have 1/2 squared, that's 1/4. 1/2 times 1/2 is 1/4. And then we're going to have root 3 squared is 3. So then that's just going to be 3, and then 2 squared is 4. So we have 1/4 plus 3/4 equals the square root of 1, which equals 1. So r equals 1 in this situation, which is going to be very handy for us, we will see. So now let's just go plug in all our numbers. Our hypotenuse is 1, right? And then our opposite is root 3 over 2. And our adjacent is 1/2. So we can simplify these a bit. Root 3 over 2 over 1, that's just root 3 over 2. 1/2 over 1, that's just 1/2. And then root 3 over 2 over 1 over 2 is the same as root 3 over 2 times 2, which is root 3. And so those are going to be our answers for this one. So let's go plug those in. And it looks like they all check out. So, referring to the last slide, complete the following sentence. When the radius of the circle is 1, the sine and cosine values. Well, what we saw happen was that since the radius of the circle was 1, that the sine value just ended up being equal to the length of the opposite side. So root 3 over 2 was the length of the opposite side, and that was what our sine was, because dividing by 1 just doesn't change anything. And the same thing happened with the cosine with the adjacent value, right? It was 1/2 divided by 1 is 1/2. So the length of the adjacent side is equal to the cosine. So basically, the side lengths of the triangle are equal to the sine and cosine. All right, so now we're going to start kind of building our unit circle. So we want to drop, we're going to look at the 30-degree angle. So we're going to drop that from here. 30 degrees is 1/3 of the way around a half circle, or a quarter circle, I should say. It's that 1/6. So this is our 30-degree angle. This is the reference triangle that goes with it. So here is our angle, and we are going to try and figure out. So we know the hypotenuse here is 1, just like on that last one, because the radius of the circle is 1. The radius of the unit circle is 1. So that means any line we draw from the center of the circle out to the edge is going to be 1, which means any hypotenuse on our reference triangle is going to be 1, and that's going to be really handy for us because these side lengths are then going to become our sines and cosines. So we've got this 30-degree angle. So the side length here, we know from the 30, 60, 90 triangle in our notes, or we could go look back at an earlier slide I think we had, but here, I'll pull it up. So this is the special triangle section in the page 1 of the notes. But we can see we're looking at 30 degrees. So the cosine of 30 is going to be square root of 3 over 2. So then the adjacent side here must be square root of 3 over 2, which is x, right? The over, the run is x. So square root of 3 over 2. And then the height here is going to be 1 over 2. So it's 1/2. Now we're looking at a 45-degree angle. So that's just going to halfway from 0 to 90. And then we're going to make a reference triangle. So the fun thing about a 45-degree, 45, 45, 90 triangle is that both side lengths are the same. So we can take the sine of either side. It's going to be equal to the cosine of either side. The sine of 45 is root 2 over 2. The cosine of 45 is root 2 over 2. So if we look at this, that means that the sine of this angle is going to be equal to the cosine, and they're both root 2 over 2. Just copy it. And that'll be a nice thing, that one less thing to remember when we're doing this later. Let's see, now we're doing the 60-degree angle. So from here to here about, 60 is 1/3 of 180. So it's going to be, this would have been dividing the whole thing into 3. So that's our 60-degree angle. Here's going to be the reference triangle. And there's our angle right there. So once again, we're working with 1 as our hypotenuse. And so we're going to look again at the 30, 60, 90 triangle, and we're looking at 60. So our adjacent is 1/2. Last time it was opposite. Now it's adjacent is 1/2. And that's the x value. So it looks like the cosine or the x value is always going to be, or the cosine or the adjacent is always going to be the x value. And then the rise must be square root of 3 over 2. So this is one of the easier ones. The angle is 0, right? So we're just literally going from here to here, and that's it. What is the x-coordinate? The x-coordinate, remember, this is 1. That's the radius of the circle. And the y-coordinate is 0 because it didn't go up anywhere. And then the next angle is 150 degrees. So I know 150 is 30 degrees shy of being 180. 150 plus 30 is 180. So I'm going to do it like here, kind of very similar to the angle I drew for 30 degrees here, except on the opposite side of the y-axis. So there's my 150. On this one, it's slightly different. So I know I'm looking at the sine of 30 to do my y value. So the sine of 30 is going to be this height. It looks like 1/2. And then the cosine of 30 is negative square root of 3 over 2. And it's important to make that negative because we're in the second quadrant and all your x values are going to be negative over here. And so if you plugged in to a calculator cosine of 150 degrees, remember this is the 150-degree angle, you would actually get a negative number. And this is kind of how we're going to be able to find cosines and sines of numbers that don't really fit in triangles, like 150 degrees. And that is it for this activity.